Hello friends, I'm back with another video and this time it's scalability. Today we'll understand how scalability impacts all the applications, or I should say super applications across the world who serve more than thousands, millions of customers. And this concept is very important while you're building a super application, because an application which is very fast, okay, for a limited number of customers, and which dies down for a huge number of customers, is not a slow app. It's missing something called as scalability, and we'll understand what that scalability is. So let's dive into it. Okay, so I'll start with the analogy which I gave in my last video as well, where instead of having a one big restaurant, okay, you are going for a food court model, right? For example, if you have a lot of customers who are uh, having options as multiple outlets in a big food court, okay, and uh, let's say your customers are going for a biryani stall. Okay, now this stall or this outlet is a single outlet, and all of a sudden if there is a surge, okay, that means too many customers are coming to this biryani outlet, and this biryani outlet is very much popular. By the way, this can be sandwich, this can be South Indian, okay, South Indian, this can be Punjabi, okay. So when we talk about this outlet model, okay, and if there is a surge of too many customers, what is going to happen is that this biryani outlet, the kitchen, the cook, the manager, they may get overwhelmed and they may not be able to support these many customers at a single point of time. So you imagine if there are two customers, they were doing good, everything was hunky dory, and they were able to serve their orders in the appropriate amount of time. Okay, now I'll just zoom out this biryani outlet for you, so that I'll say biryani outlet. So once the customers were coming over here, okay, you had one manager, maybe one cook, and a kitchen which was serving these customers, where the customers number was less. If the customer number increases, okay, let's say there are more customers coming in, what is going to happen, this one person who's actually taking the orders and the one cook will not be able to serve these requests, right? So how do you solve the situation? One way to solve it is basically you add one more, let's say, manager, or the person who takes your orders, one more person, so that simultaneously those orders can be taken. You maybe add one more cook and maybe a small kitchen over here, right? So this will help you handle this additional load which is coming on. Okay, this type of scaling means nothing but increasing the resources or services which are available. So this type of scaling, where within the outlet itself you are increasing the number of maybe resources or components servicing the request, is called as vertical scaling. Okay, it's called as vertical scaling. That means within the outlet itself you are actually increasing the number of resources who can serve the request. But there is a limitation, because for example, if more customers come in and they try to access this biryani outlet and request for biryani, what is going to happen is that even these two will not be sufficient. You may need to add the third one, but then how will you add the third one, because there is no space in this outlet. Now you cannot add a third kitchen as well. This problem you will hit, this is called as a ceiling effect where you have hit the ceiling, now you cannot add more resources, right? So in that case, vertical scaling is always has a limitation. Okay, now if I compare it to the actual IT components, you can imagine that this is a server and you have CPU and RAM, and you can increase the CPU and RAM so that the hits which are coming from the multiple customers can be served. Okay, so vertically you can increase CPU and RAM within the server itself. That part is called as vertical scaling. Okay, and there is a limitation because the CPU slots, the RAM slots in the servers are a fixed number, right? If you have 5 RAM slots, after putting 5 RAM chips into it, you will not be able to add the third one. So vertical scaling has a limit. Now, what is the other type of scaling in that case? I'm just repeating vertical scaling again and again. So there is something called as horizontal scaling. So what is horizontal scaling? For example, coming to the same biryani outlet example, if I build an outlet altogether, if I build a new outlet altogether, okay, exact copy or replica of this outlet, this type of scaling where you get new resources over here, new kitchen, new resources, new kitchen, right? This type of scaling is called as horizontal, horizontal scaling. Okay, where you have a server which with limited CPU and RAM, but then you add another server with limited CPU and RAM, then you add another server with CPU and RAM. What happens is that now you have multiple servers actually servicing the requests, right? Like this. So now you have three different biryani outlets, but these are replicas. They have the same biryani flavor. They have the same similar kind of kitchen. They have similar branding. They have similar taste, right? So similarly, in an IT example, if you have some application running on these servers, it will be replicas, and this application can be served from multiple servers. This type of scaling is called horizontal scaling, and if you scale within the server itself, within the outlet itself, that is called as vertical scaling. Okay, I hope I am clear till now. Now I would like to first of all, I'll give you some examples when this happens. So for example, if it's a banking application and there is a salary day, imagine, right? Maybe at the end of the month, you can imagine the surge of transactions which will happen, and the people who will actually log in into their accounts and check whether salary is created, and they will want to know how much created, how much is their balance, right? uh, Maybe Flipkart, you have Flipkart big billion days, right? Well, where so many customers will log in into the system. So you were serving with one or maybe two instances, now you need three, maybe you need four also to handle the additional customer load, right? Similarly, I think I have heard Amazon Prime Day, correct? Again, there is a surge in the customers who are accessing this application, right? So this is where your this comes into picture, your horizontal scaling and vertical scaling comes into picture. And do remember that in most cases it is only horizontal scaling because it is much more flexible and easier to do. So for example, if I go to my last two videos where I explain load balancing and as well as monolith versus microservices, imagine there is a Amazon application which is running on microservices or pods or containers. So what will happen is that if there is a surge of customers on Amazon Prime Day, these pods will automatically scale. There will be multiple pods who can actually handle the request. Okay, so this is called as horizontal scaling, and this is very easy to achieve. So I mean, in fact, this is automated also. You can have something called as HP horizontal pod auto scaler. This is a Kubernetes feature where automatically if the surge goes up, okay, so when I say surge goes up, there is a threshold in the sense if the CPU crosses, let's say, 70% and RAM crosses 70, either of this, by the way, not necessarily both have to cross 70%, either of this, if it crosses 70% per pod, automatically a new pod will spin up. That means the system will actually look at all the pods servicing a particular service or application. If it crosses 70%, another pod will be spun. If this also including crosses 70%, then another pod will be spun, right? So that is how your thresholds are configured, so that automatically the pods are auto scaled. Now imagine if these thresholds are not configured, and what happens if it reaches 100%? Yeah, you guessed it right, the application or the pods may go down, right? If they go down, then what happens is your application is not available, right? So that's the reason it is very important you set up thresholds, so that at a particular threshold the pods may auto scale, and you will have these new pods to service, right? This is difficult in case of here it is difficult to actually set up vertical scaling, because in vertical scaling automatic CPU and RAM increase will not happen, and even if it happens there will be a limitation, because if the server only has a capacity of some CPU and some RAM max capacity, the ceiling effect, then you will not be able to scale it beyond the max capacity. That is the challenge. Okay, so remember that. Coming to one more part is important, that horizontal scaling, as I explained in my last video also. If you have one minute, if you have let's say one outlet, when I said, right, and you have people coming in over here, okay, this one outlet, if even if I do a vertical scaling over here, adding more and more resources, if this one outlet goes down, anyways your application is totally down. But if you do a horizontal scaling, what you can do, maybe these are pods, horizontal scaling, you can always add a load balancer, which we discussed last time, right, which will balance the load like this, right, between these three outlets or services or pods, and this will help you avoid single point of failure. Okay, this will avoid single point of failure. That means there will be no single point of failure, and if one pod goes down also, then also you will be able to serve the request from other pods. So this load balancing gives you that advantage of your application to be always available. You must have noticed, right, whenever you access Amazon, whenever you access Flipkart, it rarely happens that the application is not available. This is the reason, basically, because these it is all automated, right? It automatically scales. It can automatically scale down as well. Basically, there is no load. It load balances, so that your application is always available. Okay, the last part which I want to explain is that I only explained you the scaling part, where I said horizontal versus vertical. But imagine in a real world, when the application is accessed, coming back to our example of via internet, then it goes to your data center. Now data center may have a lot of components. For example, you may have a router, you may have a firewall, you may have web servers, you may have security WAF servers, you may have API gateway, right? Now this scalability effect actually applies to all, by the way. I took only the app server example, like I talked about pods, microservices, or maybe VMs, okay, which can scale, but actually all these can scale. API gateway, web servers, you can have multiple instances horizontally scaling out, you can have multiple firewalls. But with respect to firewalls, routers, WAFs, ideally how it happens, maybe if I take an example of private cloud, you always have 10x capacity, okay, already available in these systems, because you cannot, it's very challenging and difficult in a private cloud environment where you have physical devices to scale out, or in fact scale up. So vertical scaling is also called as scaling up, by the way. So it's very difficult to add CPU and RAM into these devices, right? So they are always like 10x capacity or more capacity already provisioned, so that the when a surge comes, you don't need to manually go and do this, right? So they are already oversized always. But your other components like API gateways, web servers, here you have flexibility either to increase the pods or the VMs also horizontally. Okay, so keep that in mind. Unless and until you are using a public cloud instance of these devices like routers, firewalls, and web, where you have these services available on SaaS, which provide you the flexibility to actually scale up and scale out. Okay, so here I have almost completed my 10 videos as a part of system design series. I hope you liked it, and please do watch all the videos. You can anytime come back and watch the videos. If you have any concerns, put any comments. If you have any queries also, if you want me to make videos on some other topics as well, please feel free to comment and ask for those videos. And if you have liked the if you like the videos, if it is informational for you and you have derived some knowledge out of it, then please do like and subscribe and share with your uh, peers or your known IT engineers. Thank you. Thanks a lot for watching the video. Thanks once again.